Okay, here we go. 9.6 part 2. Isn't that flower pretty? Thought it might be better to look at than conic sections, but alas, we have to do it. So let's finish this. All right, let me focus because it probably would help. Okay, here's part 2 of 9.6, the last section we have to do in this chapter 9. So I kind of wrote here that you might want to write this down. But what we have to do is we have to look at the equations and we have to identify the line of symmetry for the conic section. And you always have to remember that the line of symmetry, or symmetries, go through the center. If it's a parabola, it's only going to have one line of symmetry, and it's kind of what makes it fold in half exactly. An ellipse, a circle, and a hyperbola are all going to have, well, the circle has an infinite number. The ellipse and the hyperbola have two places where you could fold it exactly in half. So let's just tackle some of these, and we'll see what's going to happen here. So really what you have to do is you have to kind of just identify what it is. And right here you can see that there's a plus sign, it's equal to 1, there's nothing in front, so this is an ellipse. And it's going to be a horizontal ellipse because A, the bigger number, is under the x. So it's a horizontal ellipse. It also might be helpful just to go ahead and identify the center, which is HK. Remember that HK is equal to 5, 0. So if you make just a little sketch, it might be helpful for you to figure out exactly what we're doing here. So the center is at 5, 0, and it's a horizontal ellipse, so I'm just going to kind of sketch it here, what it might look like. Something like that. All right, now, we want to find the line of symmetries. You need to know, like I said, that the line of symmetry always goes through the center. So if I were to fold this ellipse here, that would be one of the line of symmetries, and it would fold it exactly in half. And if I were to fold the ellipse here, that's another line of symmetry because it cuts it exactly in half. And since it goes through 5, 0, we know the equation. We know that the equation of this line of symmetry is x equals 5. And the equation of this line of symmetry is y equals 0. As easy as that. All right, so let's look at this one. This one here, you can see that there's only one square, and so that means it's a parabola, and that this is a positive here, so that means it's going to be a parabola that opens up. All right? Obviously, you don't always have to write this down. I'm just kind of doing it as we are learning how to do these. It's a parabola that opens up, and if we identify the center, HK, it is going to be -5, +2. So if you kind of just want to make a sketch, I think it kind of helps a little bit. -5, +2, that is the center or the vertex in the parabola, and it opens up. Now, remember I said there's really only one line of symmetry in a parabola. There's only one line where you could cut it in half, and it's right there. And the equation of that line is x equals -5. So that is the line of symmetry. Let me put a box around here too. Those are the two line of symmetries for the ellipse. Okay, the last one we have here. Obviously, we've got a square, and it's equal to 1, and it's a minus, which tells me that it's a hyperbola. It's going to be a hyperbola on the x-axis. The branches are on the x-axis because x is first. So I could make just a little sketch for myself if I need to. All right. HK is going to be 1, 2. So the center of this hyperbola is over 1 up 2, about right here. Okay, there's the center. And I know that my branches are going to come off of here, and they're going to be something like this. I'm not sure exactly what, but I'm just going to sketch it. Now there's two places I could fold this graph so that this branch would lie on top of this branch. And I could also fold it this way, so this half of the branch could lie on that branch. So like if I do these little lines here, you'll see what I mean. So if I fold it this way, that's going to be a line of symmetry. And if I fold it up, that would also be a line of symmetry. So just having this point, I can then write the equation. I know this line is going to be y equals 2. So my first one is y equals 2. And the equation of this line of symmetry is x equals 1. So that's kind of all you do for those. Not too bad. Last thing we have to do is we have to classify, meaning name what kind of conic section it is, using the equation. And then we have to write the equation. We have to clean it up a little bit so it's in the right form. So these are, remember discriminant? We looked at discriminant when we were doing Chapter 4 in quadratic formula. And it kind of tells you here if the discriminant is less than 0, and b is equal to 0, and a is equal to c, you're working with a circle. Here, b squared minus 4ac is less than 0, it's an ellipse. b squared minus 4ac is equal to 0, it's a parabola. I know this is a little off, I'm sorry. And b squared minus 4ac is greater than 0 is a hyperbola. All right, now, probably need to back up here and take a look at this equation. Any conic can be described by this second degree equation in x and y. This is kind of going to help us set up our discriminant. So you got to keep an eye on that as we're working through this. And remember that b squared minus 4ac is the discriminant. And in quadratic equations, it told us how many solutions and what kind of solutions we had. Here it tells you what kind of conic sections they are. So here's how you go about doing this. The directions say classify the conic section and write its equation in standard form. First thing you do is use the discriminant to find it out, figure out what conic it is. Second thing you should do is write equation using, oh, look at that, completing the square, which we practiced in class. All right, so for the first one, I'm just going to identify what A, B, and C are so I can find the discriminant. So A is in front of x squared, which is 1. B is in front of xy, and there isn't one, so that's 0. And C is 1. If I stop right here and notice up here that B is equal to 0 and A is equal to C, that means that this is going to be a circle. So there you go, it's a circle. So now, once I've identified that, I know that I need to kind of work towards writing the standard form of the equation, which is going to be something like this right here, standard form of a circle. So it's going to look something like that. All right, so I'm going to write that here. X minus h squared plus y minus k squared equals r squared. This is kind of what I'm working towards, and I know I have to use completing the square. So what I'm going to do is I'm going to look at what I have here, and I'm going to kind of rearrange it. There's no way I complete the square with the order that it's in. So I'm going to write x squared minus 2x. I know I'm going to complete the square with that, so I'm just going to put parentheses around there, plus y squared plus 4y. Oh, look, I can do another completing the square there. I'm going to move the 1 over to the other side, minus 1. Now I've kind of got it set up to complete the square for both of those things, which will eventually end up looking like this, the circle equation there. All right, so remember I got to take half of b and square it and add that in. So it's going to be plus negative 1 squared, and half of b here and add that in, so it's going to be plus 2 squared. But don't forget, if you add it into this side of the equal sign, you have to also balance it and put it on this side. So this is going to be adding a 1, and this is adding a 4, so I'm going to add 5 here. All right, let's rewrite it to make it look a little pretty. This we can write as x minus 1 squared. This we can write as y plus 2 squared equals 4. Look at that. It's the standard form of a circle. And we can tell just by looking at it that h and k, not that we need to know that, but h and k are 1, negative 2. 1, negative 2. Pretty nifty, don't you think? All right, let's do this next one. So the first thing I'm going to do is identify what kind of conic it is by using the discriminant. So let's say A, B and C. Let's see, A is in front of x squared, that's 2. B, there is no 2, 0. And C is 1. So if I do B squared minus 4AC, I have 0 squared minus 4 times 2 times 1. That would be 0 minus 8, negative 8. And if I go up here, it says right here, if B squared minus 4AC is less than 0, then you're working with an ellipse. So I know I'm working with an ellipse. That's using the discriminant right there. Okay, so the general form of ellipse, I know, looks like this or like this, depending on what number is bigger on the bottom. So I'm going to be working towards that. So let's see what I have here. I can move stuff around, and I'm going to add 4 to the other side so I can begin to maybe complete the square. So I'm going to group the x's, and I know I'm going to complete the square with that. And then I have a plus y squared. Oh, I probably don't have to do anything with that. And then I'm going to bring the 4 over to the other side, equals 4. Okay, now I can complete the square. Oh, no, can't complete the square because that has to be 1. So I'm going to divide out a 2, which is perfectly legitimate, just out of this part right here. X squared minus 2x. Just as long as, well, I'll talk about that in a second. Okay, now I'm ready to complete the square with what's inside of here. Divide this in half and square it, which means I'm adding in a negative 1 squared. Okay, now remember over here we said we have to keep it balanced. So I'm adding in a 1 here, but really I'm adding in a 2 because of this 2 out here. So over here I have to add a 2. So be careful of that when you pull something out like that. All right, let's write what we have now. Equals 6. I'm getting closer to an ellipse, but in an ellipse this cannot be, this has to be 1. So I'm going to divide everything by 6. And look at this fraction right here. I can reduce that fraction. It would become 1/3, which basically just leaves the 3 in the denominator. Now it's kind of looking like it's supposed to. Well, that's it. There you go. That's my equation of my ellipse right there. Nifty. Okay, just a couple more. Obviously we have to do a parabola and a hyperbola. But if you were just looking at this, you could probably already tell that it's a parabola because it's only got 1 square in it like this. But let's just use the discriminant just to be sure. A equals 0 because there is no x squared. B equals 0, there's no xy. And C equals 1. So if I do b squared, which is 0 squared, minus 4 times 0 times 1, it's just going to be 0 minus 0. And it says right up here, if b squared minus 4ac is equal to 0, you're working with a parabola. So I know it's a parabola. All right, and I know here, I see here that it's the y squared, so I know if I look at the other side here, this is the standard form of a parabola with the y being squared. So I'm just going to write that down. This is what I'm working towards. Okay? All right, so kind of look at what we got to do here. We have to keep the y's on this side, and everything has got to be moved over to the other side. So that's what I'm going to do. I'm just going to kind of keep the y's here, leave a space for completing the square, and I'm going to add 2x to this side and subtract 6. So it's going to be 2x minus 6 over here. All right, let's complete the square with this. If I cut this in half and square it, I'm going to be adding in a negative 2 squared. Obviously, you've got to add the same thing to the other side. It's just going to be adding 4. And let's write this a little prettier. This now becomes y minus 2 squared equals 2x minus 2. But we always want to double check because it doesn't quite look like this yet. We need this to be 1, so we can divide out a 2 here. x minus 1. Oh, there we go. We did it. That is the parabola. Okay, last but certainly not least, you could probably guess we got to do a parabola. So if I come over here and I identify A as 4, B is 0, you're probably seeing that pattern. B has been 0 for all of these. And C is negative 1. And if I do B squared minus 4AC, 0 squared minus 16, I'm going to get negative, excuse me, it's going to be 0 plus 0 squared plus 16 when I put that all in there. And it says right here, if B squared minus 4AC is greater than 0, it's a hyperbola. Alrighty. Don't panic. I'm going to give you these so you don't have to memorize them. Okay, they'll be on the board for you. Alright, so now that means we are working with hyperbola, either this one, be sure we keep a minus in between there, or this one. It depends on what, we'll see what happens here. Okay? So, first of all, we want to again group because we're going to have to complete the square. So I'm going to group my x's together. 4x squared minus 16x. Okay, now remember with a hyperbola, we have to have a minus. Well, I'm just gonna write it like this. And I'm going to group my y's together. But remember, I have to have a minus here. So that is going to make what goes inside here a positive y squared. And that's going to make what goes inside here a positive 4y. Because think about it, if I distribute this out, then I would get what I started with. So this has to be a minus in order to write the standard form of a parabola. And then I'm just going to bring the 4 over on the other side. So we're starting to formulate that hyperbola, excuse me, I said parabola I think before. So now I see that I can pull out 4 here, which I need to do. I need to pull out a 4, and then I'm going to leave space for completing the square. X squared minus 4x. Leave space for completing the square. Minus, can't pull anything out of there, but I am going to include a spot for completing the square. Equals 4. Half of negative 4 is negative 2 squared. I'm going to add that in. Negative 2 squared. Half of positive 4 is 2. I'm going to add that in. Okay, now, let's see what we're actually adding on to this side of the equation. We're adding on a 4, negative 2 squared, times 4. So we're adding on a 16. So we have to put that there. Here is a little tricky because we're adding on a 4, but actually because of the minus, it's a negative 4. So I have to put the same thing on this side to keep it balanced. All right, now let's just kind of make it pretty here. So this becomes x minus 2 squared. I'm going to know I have something underneath there, so I'm going to put a minus with a line there and put a minus. And then y plus 2 squared. Put a line underneath there because I know there's going to be something there. And then this is equal to 16. Oh, I can't have it equal to 16 if it's a hyperbola. It has to be equal to 1. So I'm going to divide everything by 16. And then I should be able to come up with my final equation. This fraction right here, 4/16, can be reduced. So it's going to be 1 over 4. So actually in the numerator I'll have x minus 2 squared over 4, that 4/16 reduced to 1 over 4, minus, this just stays the same, can't reduce anything there, equals 1. And there we go. All right, you did it. How smart you are now.